have started the recording now for today's class. So today we're going to start with the idea of chain reaction and nuclear reactor. How does it work and what actually goes around? So এই পার্টটা এখান থেকে একটু পড়া শুরু করো, আমি তারপর বুঝাচ্ছি। Go ahead. পড়া যাচ্ছে? ফন্ট সাইজ ঠিক আছে? Thank you.
Yes sir, ঠিক আছে। Sir, the question inshallah. Sir.
পড়া হয়েছে একটু?
স্যার আধা মিনিট।
তাকে আমি আদনান সামির ইয়াতে চ্যাট উইন্ডোতে একটা মেসেজ পাঠাইছি, দেখো তো সলভ করা যায় কিনা।
জি স্যার।
I will be grateful. ইন্টারনেট শব্দ আসতেছে?
স্যার আমি দেখছি স্যার।
না না, তুমি আগে এটা পড়ো, ওটা পড়ে ক্লাস শেষ হওয়ার পরে ওটা সলভ করো, এখন না। ইটস নট ইমার্জেন্সি।
ওকে স্যার, ওকে স্যার।
ক্লাস শেষ হওয়ার পরে কারণটা পড়ো। জসিম কিছুক্ষণ ঘুমায় না বাবা।
স্যার আমার একটা প্রশ্ন ছিল স্যার এই এক্সপোনেনশিয়াল ইনক্রিজ জিনিসটা কি একটু বুঝাবেন
এক্সপোনেনশিয়াল ইনক্রিজ হচ্ছে
বা
জিওমেট্রিক ইনক্রিজ।
এক্সপোনেনশিয়াল ডিক্রিজ এক্সপোনেনশিয়াল চেঞ্জ বেসিক্যালি
আচ্ছা, এক্সপোনেনশিয়াল চেঞ্জ মানে হচ্ছে সাম সর্ট অফ চেঞ্জ দ্যাট গ্রোজ জিওমেট্রিক্যালি। জিওমেট্রিক্যালি মানে হচ্ছে লেটস সে 2 থেকে 4, 4 থেকে 8, 8 থেকে 16, 16 থেকে 32. So your delta increase or মানে delta change is mathematically doubling by a ratio, not by amount. For example, 2 থেকে 4, 4 থেকে 6, 6 থেকে 8, 8 থেকে 10, এটা হচ্ছে arithmetic growth. আর 2 থেকে 4, 4 থেকে 8, 8 থেকে 6 এটা হচ্ছে জিওমেট্রিক গ্রোথ। জিওমেট্রিক গ্রোথ কে আমরা বলি হচ্ছে এক্সপোনেনশিয়াল গ্রোথ।
Oh, another name for geometric growth is exponential growth.
এক্স্যাক্টলি
Sir. Sir, ওই রিঅ্যাকশনটা চেইন রিঅ্যাকশন বলছি because it can sustain on its own because once started দুইটা নিউট্রন বের হয় breaking down two more atoms releasing four
নিউক্লিয়াই, two more nuclei.
sorry sir
Two more nuclei.
oh sorry two more nuclei আচ্ছা স্যার
হ্যাঁ বলো।
nucleus is when it is part of the atom and nuclei when it is on its own, right?
Not essentially. Every nuclei is part of an atom, but whenever we talk about nuclear fission or chain reaction sort of thing, it is important that you specify exactly what is breaking up, because that choice of words can vary in terms of how much mark you're gonna get. So being specific helps. Whenever we write any nucleus in the nuclide notation, for example, let's say if we write that carbon 12 মনে করো হচ্ছে C612 এই ফর্মেটটা লিখলাম, writing this symbol means that we are talking about changes that might occur to this nucleus. We are not at all now bothered about the orbital electrons. Orbital electrons might do whatever they want. We are now concentrating on the nuclear part of the atom, and we're concentrating on the change of the nucleus. It doesn't necessarily mean that that nucleus is existing on its own. No, it doesn't mean that. It is definitely part of atom, but we are concentrating on the nucleus part.
Yes sir, which is why we call it nuclei.
No, nuclei is the plural of nucleus. Nucleus is plural হচ্ছে nuclei. That notation is called nuclide notation. Nuclide notation. It's a way of expression.
Yes sir.
Sir,
Yes.
sir, I had a question about nuclear fusion.
বলো।
Sir, is helium heavier than two hydrogens?
What do you mean by heavier in this case?
Like when they two fuse together, is it like does the mass reduce or does the mass increase?
Whenever 4 hydrogen atom combine into one helium nucleus, in that process 2 protons remain proton and 2 of the protons convert into neutron. In this entire reaction, some mass is released, some mass is lost. Or if I give you some mathematical idea, let's say if each proton has a mass of, let's say, 10 kg, then the total mathematical sum of 4 proton will be 40 kg. But once Sapat. But once they combine into a helium nucleus, the total mass of the helium nucleus will be somewhat smaller than 40 kg. Let's say it will be 38 kg or so. 2 kg worth of mass will be converted into energy.
Okay, sir.
The 2 kg worth of mass will be converted into the types of energy, right sir? Light energy and
Light energy, heat energy, yes.
স্যার
Yes.
স্যার প্রাইমারি কুলেন্টে এটা বুঝি নাই।
হ্যাঁ, এই কুলেন্টের সাইকেলটা আমি একটু পরে একটা ইয়া দিয়ে দেখাবো, ভিডিও দিয়ে দেখাবো। ডোন্ট ওয়ারি অ্যাবাউট ইট। এই পর্যন্ত পড়া হয়েছে সবার? এই ফ্লো চার্টটা বুঝা গেছে?
স্যার ওই
ফ্লো চার্ট বুঝে গেছে স্যার।
বলো, ইয়া বলো, চন্দ্রিমা বলো।
প্রাইমারি কুলেন্টের পার্টটা কি পরে বুঝাবেন?
এই যে একটু পরে একটা ভিডিও দেখাবো, তারপর বুঝাচ্ছি। এই পর্যন্ত পড়া হলে ঠিক আছে, আমি এরপর তোমাদেরকে একটা ভিডিও দেখাচ্ছি। ভিডিওটা দেখানোর পর তারপর আমরা ফার্দার কোশ্চেন নিব। জাস্ট হোল্ড দ্য হোল টাইট, লেট মি পুল দ্যাট আপ।
স্যার একটু ওয়েট করেন স্যার।
কি বুঝলা?
মানে একটু ইনএফিশিয়েন্ট লাগলো।
আচ্ছা, এই পর্যন্ত আমি পুরো ভিডিওটা দেখালাম। এখন আমি ডিফারেন্ট লোকেশন চুজ করে ডিফারেন্ট জিনিসগুলো বুঝাবো, আর এখন আমি ভিডিওটা ফার্দার প্লে করবো না, কারণ নাহলে আমার
Nuclear react.
ঝামেলা দেবে। বেসিক্যালি যেটা হচ্ছে যে what I need you to understand that within the nuclear reactor, we're going to have some fission elements, which is going to be the nuclear rod, and there are going to be some moderators. The purpose of the moderator is to slow down the neutrons, which are going to be produced from the nuclear fission reaction, so that they can be absorbed effectively onto the neighboring nuclei. Here's the deal. Let's say, try to understand, to make sure a subsequent chain reaction can follow through, we have to ensure that the neutrons which are produced from one fission reaction, they should hit the nuclei of one neighboring atom, uranium atom, and get absorbed in the nucleus. That's important. So the neutron should get absorbed in that nucleus, making a very temporary isotope of, let's say, uranium-236, because 235 plus 1 gives you 236. And after that thing, that uranium nucleus would break down into two daughter product and energy will be released. So we have to make sure that these neutrons, which will be produced out of the chain reaction, will be absorbed by the neighboring nuclei. To make sure that they do this, we have to maintain the energy, we have to maintain the speed of those neutrons to a moderate level. Typically, the type of energy that that any chain reaction or any nuclear fission gives, the type of energy that the neutrons get from the breakdown of the fission reaction is usually quite high. If I give you some number comparison, let me put this in this way. Let's say there is a nuclear product, there is a uranium nucleus, and you are shooting a neutron towards it. Let's say if the energy of the neutron is 50 joule, just to make sense, it is gonna penetrate into the uranium and it's gonna stay there. But let's say if it is more than 50 joule, it is gonna be able to penetrate through the nucleus and go out. If that happens, then you would not have successful chain reaction, because that is possible because the nucleus would not repel the neutron. Neutron is a neutral particle, so the nucleus being positive would not do any repulsion on them. So it is important that we have to maintain the speed of those neutron to a moderate level. That's where water comes in. So water slows down the
Sir,
neutrons.
moderate level এ বেশি থাকলে কি হয় আরেকবার বলবেন?
The neutron can penetrate through the nuclei and penetrate out, so that it would not actually merge with the uranium nuclei and do the fission reaction. To make sure the fission reaction happens, you need to provide the neutron, you need to direct the neutron towards undecayed uranium nuclei with a moderate level of speed, so that they would hit the neutron, they would hit the nucleus and get absorbed there. They should not penetrate through and leave on the other side.
Sir, penetrate হওয়ার পর it destabilizes the uranium nucleus too.
No, if it penetrates through, then it will not destabilize.
But absorb হয়ে গেলে it will destabilize the nucleus such that it breaks down, releasing much
Exactly.
and many more neutrons, right?
Subsequent neutrons, exactly. So typically the type of energy that any nuclear fission reaction gives to the neutrons, let's say within the range of, let's say, 100 200 joule. But to make sure that these neutrons would be able to do subsequent collision with the neighboring nuclei and do further chain reaction, we need to slow them down a little bit. Not altogether, but down a little bit. So that's why the water comes. That's one purpose of the water. And this will keep on happening at its own pace, but we cannot allow this chain reaction to build up like a nuclear bomb. We have to control this chain reaction that exists in a nuclear reactor, so that the rate at which the heat energy will be produced, we can keep on extracting that heat energy. The idea is very simple. If the reactor produces, let's say, 2 gigajoule per second, you have to have an efficient way to remove the 2 gigajoule amount of energy per second. If the reactor produces 2 gigajoule of energy, and if you are removing, let's say, 1.8 gigajoule of energy, then every second you will be storing 0.2 gigajoule of energy within the reactor, which is going to increase the temperature of the reactor, and that is basically how meltdown happens. We need to make sure that the rate of energy produced from the fission reaction should be exactly same as the energy that is extracted out of the reactor every single second when you need time. That is really, really a important factor. That's exactly where this water cycle come in. Have a look at this water cycle. So this is the nuclear reactor, which is submerged into water. We have a water cycle over here. This is what we call the primary cycle. The purpose of the primary cycle is to take heat energy from the nuclear reactor, go through a heat exchanger. This container over here, this is what we call the heat exchanger. The heat exchanger absorbs the heat. The heat exchanger, I mean, within the heat exchanger, these are steel pipes, and this container is also made up from steel. So this is something like the, just small intestine of human beings or other stuffs. This is a spiral structure of metal tubes through which the primary coolant is essentially water, but typically it is made from deuterium oxide. It means it's not H2O, because you should know that hydrogen has how many isotopes? Do you know this thing?
3 isotopes.
3.
Three isotopes. First one is called what?
Proteum.
Proteum. Beautiful. The regular isotope is called proteum, and the second one, the hydrogen 1, 2 is called deuterium, and the third one is called tritium. Naturally occurring sources, about 99.8% of the hydrogen is proteum. About 0.2% is deuterium, and tritium is extremely rare, like super rare, naturally occurring hydrogen. So typically, this water is usually made from D2O, deuterium oxide. The primary coolant water is made from D2O. This actually makes the specific capacity of the water significantly higher than regular water. If you wonder why, here's the deal. Specific capacity means what? Amount of heat energy required to increase 1 joule of temperature, 1 Kelvin temperature for 1 kg, right? So if you think for the deuterium, I mean, there are some certain benefits for deuterium oxide. One of the benefit is that it has higher specific capacity, which is not a part of the syllabus. I'm just telling you why it is preferable. So this is still water, but it is made from preferably it is made from the D2O, which is the deuterium oxide. D2O means the deuterium isotope. So this water actually takes up this heat, and this water is kept at a really high pressure. Have a look. Within this temperature, the temperature of the reactor might as well be in excess of like couple of 1,000 degrees Celsius. It's possible. But this water is kept under extreme pressure so that it will always be in liquid state. This is a similar scenario like what happens in pressure cooker. In pressure cooker, by applying pressure, we can increase the boiling point of water. So this is very much like a super high pressure pressure cooker. So the water is maintained in liquid state. The water takes the heat, goes into here, flows through the steel pipe, and exchanges the heat through the steel metal pipe to the external water, which in this case is labeled as a green. This green water produces the secondary cycle, or we can call this a secondary coolant. This water is coming down, taking the heat over here and doing the heat exchange. So a part থেকে আমাদের heat গুলো আমাদের এই green water বের হয়ে যাবে. So this will be converted into steam, and that steam would be eventually used to flow onto the turbine to rotate this turbine, and here it will be producing kinetic energy in the generator. Now, the reason why we need two different cycles is because of two things. First of all, this water that goes through the reactor also becomes radioactive over time. And we cannot allow this water to escape into the environment. Anything that you're going to blow onto the turbine, there is always a possibility of leakage and everything, but this water cannot be allowed to simply get exposed out. This is radioactive water. So we have to maintain a perfect closed cycle of the water that runs to the reactor. This water will never be let out from inside the reactor system. This is a very closed cycle, and we are going to take out this heat from this water cycle. This is basic normal water, like regular water, and that regular water will be converted into steam, and then we're going to blow into the turbine, and it keeps on happening. That's the basic energy flow path. Now, one thing that I did not cover in my discussion, তোমরা হাত উঠে রাখো, যাদের কোশ্চেন আছে হাত উঠে রাখো, আমি ডিসকাশনটা শেষ করি। সেটা হচ্ছে, how do we control the rate of the fission reaction? How do we control the rate of the fission reaction? Here's the deal. The typical idea of chain reaction is that from one chain reaction we'll be producing, let's say, 2 neutrons. Those 2 neutrons would be able to produce 2 more fission breakdown. Those 2 should be able to produce 4, and then 8. It should go on further. If we want that this kind of exponential growth of decay should not happen, if we want to have a controlled, reliable, or acceptable out of energy output, then we somehow had to make sure that exponential decay rate should not happen. So that's where the control loads coming. The control loads are made from cadmium or boron, some sort of this kind of heavy elements, which has the capability to absorb extra neutrons from inside the reactor. Those control loads have the capability to absorb neutron and hold them within themselves. So by using the control rods, we can control exactly how many free neutrons would be allowed to do subsequent reaction. If we want much more neutrons to undergo reaction, then we're going to lift up those control rods, and the neutrons would not be absorbed by those control rods. Fission would become faster. If at some point we want the nuclear reactor to produce a smaller amount of power, we're going to put down those control rods, and more neutrons would be absorbed. As a result, the rate of fission reaction would become less. But one thing is very much true: you can never make the reaction come to zero. If you stop the nuclear reaction altogether, I mean, if you have absorbed the very last neutron, then restarting the nuclear fusion is going to be a big trouble, because you have to understand that neutron hitting the nucleus, producing more neutron, is continuing the process. You can make the process slower by absorbing neutrons out of it, but if you absorb the very last free neutron, then you are not going to have subsequent chain reaction anymore. To make that subsequent chain reaction, you have to somehow rekindle the process, or you have to somehow start the chain reaction once again, which is a very difficult thing to achieve. So it's usually never done. So the purpose of the control rod is to absorb extra neutrons out of the reaction environment, so that we can control the rate of the decay in the further down the line. And also this entire thing, I mean, this is the nuclear chamber. I mean, এখানে ওরা একটা certain construction আছে, construction actually পুরোপুরি perfect না। আমি perfect একটা construction দেখানোর একটা try করি, দাঁড়াও। এই ফিগারটা অনেক পারফেক্ট। টিপিক্যালি আগে শুরু থেকে এই ফিগারটা দেখো, এই ভিডিওটা একটু দেখো, ঠিক আছে? এই ভিডিওটা একটু দেখো। আমি দুটো ভিডিওর লিংক ইনশাআল্লাহ দিয়ে দেব, যদি আমার কপিরাইট ক্লেম দেয়। তো তখন হয়তো ভিডিওগুলো না থাকবে না, বা আমার ডেসক্রিপশনে এই ভিডিওগুলো থাকবে। এই ভিডিওটা একটু দেখো, এই ভিডিওটা একবার দেখলে আরো কিছু কোশ্চেনের আনসার পাবা। দেখো এটা, তারপর আমি তোমাদের কোশ্চেন নিচ্ছি। ডোন্ট ওয়ারি।
Nuclear power plants are thermal power stations which generate electrical energy from heat. They consist of numerous buildings and facilities, the most important of which are as follows. The turbine building houses several turbines as well as the generator necessary for electrical power generation. The containment building where the nuclear reactor is housed is made of meter-thick reinforced concrete. Inside this building, nuclear reactions take place where water is heated up. The cooling tower, which can be as tall as 200 meters, is where hot water is cooled. In order to easily understand the underlying principles, the following is a description of the most important components of a nuclear power plant that uses a pressurized water reactor, PWR. In the reactor pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressurized water reactor, as in this case, the reactor pressure vessel stands about 12 meters tall. The walls are about 25 centimeters thick. Inside is where the fuel assemblies can be found. In pressurized water reactors, about 150 such assemblies are installed. A single fuel assembly is composed of many fuel rods. A fuel rod is about 5 meters in length and has a diameter of about 23 centimeters. The actual nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium or plutonium make nuclear fission chain reaction possible. In the fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going. Inside the vessel, the water is heated to over 570 degrees Fahrenheit. The water does not boil, however, since the pressurizer maintains the water pressure constant at around 160 bars. The heated water is eventually pumped to a heat exchanger. systems are always kept separate from one another.
Take a very good look at the location. This is the reactor vessel. This is the heat exchanger. All of these things are kept inside the containment building. Only the secondary water or the steam is coming out of this thing, which is fed into the turbine. These are the turbine. This is the generator. And after the turbines use up the energy, the water cools down. Then they are sent to the cooling tower for cooling, and then the liquid water comes in, and then the water is sent back to the reactor. So the primary water, the primary coolant or the heavy water cycle always runs through this pipe, which is kept inside the containment building. Inside this building, everything is radioactive. Everything is radioactive.
Water in the primary circulation system never leaves the containment building. This water is radioactive, since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. The cooling circulation system provides cool water and is used to condense the steam in the secondary circulation system.
এখন বুঝছো কিনা দেখো
স্যার
Yes.
বলো
হিট এক্সচেঞ্জার তাহলে রেডিও অ্যাক্টিভ হয়ে যায় না?
হিট এক্সচেঞ্জারটা রেডিয়েটিভ হয় না বলতে হচ্ছে the metal tubes, the amount of radioactive material that is contained in the primary coolant is not that much high to actually penetrate through the copper tubes, which is going to be responsible to the heat exchange. They are not that much radioactive. They are radioactive so that they can be released to the environment, but they are not that much radioactive that they can actually penetrate to the layer of the copper tubes.
Sir, what are moderators? I didn't understand.
বলো হ্যাঁ আব্দুল্লাহ বলো
নিউট্রন নাম্বারকে কখনো জিরোতে দিব না কেন, মানে কেন জিরো করতে পারবো?
আমি তোমাকে সিম্পল একটা আইডিয়া বলি। মনে করো হচ্ছে তুমি গ্যাসের চুলায় রান্না করতেছো, ঠিক আছে?
Yes, sir.
Let's তুমি গ্যাসের চুলায় রান্না করতেছো, you're cooking in a gas stove. By increasing or decreasing the fuel volume, you can control at what rate you want to cook, right?
Yes,
But
sir.
if you totally zero the gas volume, then to make the oven start, you cannot simply turn on the gas. You would have to require a lighter.
Yes, sir, বুঝছি। So,
Make sense? Do you see the similarity here?
হ্যাঁ, so এখন নিউট্রন যদি জিরো করে দিই, এটা আবার স্টার্ট করতে কি লাগবে আমাদের?
অন্য একটা নিউক্লিয়ার রিঅ্যাক্টর থেকে অনগোয়িং চেইন রিঅ্যাকশনের ম্যাটেরিয়াল এনে এখানে ফেলাইতে হবে।
স্যার এভাবে কি ইনিশিয়াল নিউট্রনটা আনা হয়?
নিউট্রন আর্টিফিশিয়ালি ক্রিয়েট করার কিছু মেকানিজম আছে। স্টার্টিং আপ এ নিউক্লিয়ার রিঅ্যাক্টর ইজ এ প্রিটি ট্রাবলসাম এন্ড meticulous process. আমি এটার এক্সাক্ট স্টেপস গুলো জানি না, টু বি অনেস্ট। But if someone does them, for example, let's say if there is an emergency and you need to shut down the reactor and you drop all the control rods for safety purposes, which is designed for that, it is going to reduce the it is possible that it can reduce that process to a very low, like a really really low. এখানে একটা ইম্পর্টেন্ট অ্যাসপেক্ট তোমাদেরকে বলি, সেটা হচ্ছে যে why uranium is such a good element for fission. Why not other radioactive isotopes? I mean, why uranium and plutonium are so much of interest for us? There's a simple reason for this. The reason is the average number of neutron that uranium gives out is 2.5, which means it is possible using uranium to continue chain reaction. If this number is below 1, it means it will not sustain the chain reaction. It means that you can start the reaction, but over the time the number of produced neutron number is gonna fall down and it will not sustain continuous chain reaction. So chain reaction, I mean fissionable materials অনেকগুলোই আছে, but uranium আমাদের ফেভারিট হওয়ার কারণ হচ্ছে uranium and plutonium. For uranium and plutonium this number is extremely high. As a result, they are acceptable candidates for continuous nuclear fission, which is called the chain reaction.
Sir, is lead radioactive?
Lead?
Yes, sir.
No. Lead কোনো radioactive isotope আছে কিনা আমি জানি না, but naturally occurring lead is not radioactive as far as I know.
স্যার
আচ্ছা সাবির তোমার হাত উঠেছিল, সাবির কোশ্চেনটা বলো।
Sir, what is the difference between heavy water and regular water?
একটা হচ্ছে প্রোটিয়াম ডাইঅক্সাইড, একটা হচ্ছে ডিউটেরিয়াম ডাইঅক্সাইড।
Oh, deuterium dioxide. That's a control rod ki infinite number of neutrons absorb করতে পারে, or is there a finite number?
There is a finite number, so there is a certain duration for which you can use a certain control rod. Beyond that duration, you have to replace them, and those used control rods become radioactive waste.
Oh, used control rods become radioactive wastes, which needs to be locked up for a long time, right?
Exactly.
Sir, is there no possible way যে ধরেন ionizing radiation released from radioactive substances, is it possible to use them in any way?
Usually, no, not for any. I mean, if you want to, let's say, here's the deal. I mean, if you want to, I mean, not in a productive way, as far as I can tell. Not in a productive way. I mean, let's say I run a science laboratory where I want to show the kids some radioactive effects. So I bought a Muller counter and I want to have my hands on some actual radioactive material. Maybe I might get, let's say, 2-3 gram of those stuffs which might give me significant amount of increased radioactivity over a duration of 10 years. So I might get 2-3 grams of that. That's for demonstration purpose that radioactive elements do give out ionizing radiation. Here you go. They'll look at it, have a look for this thing. Or maybe if people try to replicate the Rutherford's alpha particle experiment, then they're going to require a high alpha particle source. They might be interested in that, but these are not at all at any scale in terms of consumption rate, which is anywhere comparable to the rate of nuclear waste produced in the nuclear reactors. These are very small usages.
So the use is present, but it is not large enough to completely get rid of the waste as the waste, right?
We simply cannot do that. We simply cannot allow that even. I mean, for example, let's say if all the people in the world applies to the nuclear commissions of the UN that we all want 10 gram of nuclear waste because we want to show some demonstration, that's not going to happen. If I want to get some nuclear waste, small amount of nuclear waste, so that I can show the nuclear decay to the kids, I'm going to go through a huge amount of inspection. Do I have the necessary means and methods to actually safekeep it? Do I have the necessary means and methods and trained professional to handle this properly? Do I have any record for what can I say? Terrorist activities. অনেক ব্যাকগ্রাউন্ড চেক করার পরে ইন্সপেকশন করার পর তারপর যদি তাদের মনে হয় যে না একে দেওয়া যায় বা এই ফ্যাসিলিটিতে এই ম্যাটেরিয়াল দেওয়ার প্রয়োজনীয়তা আসলেই আছে, ফ্রুটফুল ইফেক্ট আছে, তাহলে হয়তো তারা দিতে পারে, নাও দিতে পারে, চাইলেই পাই যাবে, ব্যাপারটা এরকম না।
Yes sir, বুঝেছি।
ওকে, তা কি বলো?
স্যার ওই যেসব ফিউল রডস গুলো আছে না স্যার, ওগুলা কি পরে দিয়ে খালি হয়ে যায়, শেষ হয়ে যায়?
খালি হয়ে যায় না। This is very important. The uranium breaks down and converts into daughter nuclei. They pretty much retain their original shape and volume, but they lose a little bit of mass because mass is basically converts into energy. So they become a slightly less massive, but they pretty much stay there. But the uranium converts into something else. Khali hoye jay na. They don't evaporate. They don't vanish up, but they convert into something else which is no more fissionable.
পুরোটা ফালাই দিতে হয়?
Yes, you have to get rid of it.
আল্লাহ, কত জিনিস ফালাইতে হয়।
হ্যাঁ, that's the problem of nuclear. But there are good sides as well. I'm going to talk about the good sides as well. চন্দ্রিমা বলো।
স্যার কন্ট্রোল রডস গুলো যেগুলো নিউট্রনস গুলো অ্যাবজর্ব করে ওগুলো পরে কোনো কাজে লাগে না? the control rods,
those control rods become radioactive as well over the time as they absorb neutron. Try to understand. I mean, let's say I have given non-radioactive boron as a control rod, which is continuously absorbing neutrons, which means they are becoming the next isotope of boron, which itself will be radioactive by some amount. So when the control rods actually end up by absorbing at as most as they can number of neutrons, the whole thing is a radioactive piece of boron, which might as well have a half-life of 50,000 years, 1 million years. I have to keep them. I cannot reuse them because it's not possible for us to pluck up those neutrons from each individual atom's nuclei. That's not possible. So we cannot recycle it.
Okay, sir.
Yeah, Abdullah.
স্যার রিঅ্যাক্টরের ব্রেক মেল্টডাউন হয় কেমনে আগে বলতে হবে?
Reactor meltdown হওয়ার actual physical reason অনেকগুলো আছে, but the basic process by which it works is that যেটা বললাম যে the amount of nuclear reaction that you are having inside the reactor, you have to have a proper means or ways so that you can absorb out that same amount of heat energy that you're producing inside the reactor. If somehow your rate of energy absorption is less compared to the rate of heat energy production, then the temperature of the reactor is going to go up. At one point, your system is not going to be able to keep the pressure of the chamber that much high because the temperature has gone so up. At one point, your vessel is going to burst or melt or at least crack, and it's going to release those water in steam form. That is when the meltdown happens.
অ্যাবজর্পশন প্রোডাকশনের চেয়ে বেশি হলে তখন মেল্টডাউন হবে?
Absorption production থেকে বেশি হলে সমস্যা নাই. Your reactor temperature is going to cool down. Your reactor temperature আস্তে আস্তে কমে আসতে থাকবে, সেটা প্রবলেম না, বাট প্রোডাকশন যদি অ্যাবজর্পশন থেকে বেশি হয় তাহলে তোমার প্রবলেম। বুঝছো কি?
ইয়েস স্যার।
নাইম হায়দার, গো অ্যাহেড।
স্যার এই প্রসেসে যেসব পানি ইউজ করা হয় এগুলো সবই কি রেডিও অ্যাক্টিভ হয়ে যায়? এই ভিডিওর লাস্টে বলা হলো যে এই কিছু কিছু পানি হচ্ছে ইয়ে থাকে, এগুলো মানে ঠিক থাকে, আর কিছু কিছু রেডিও অ্যাক্টিভ হয়ে যায়।
যে প্রাইমারি সাইকেলে যে ওয়াটারটা ঘুরে মানে হচ্ছে এই যে এই সাইকেলে যে ওয়াটারটা ঘুরতেছে, এই যে ওয়াটারটা রেডিওঅ্যাক্টিভ, বাট সেকেন্ডারি সাইকেলে যে ওয়াটার ঘুরতেছে সেটা রেডিওঅ্যাক্টিভ না। এটা রেডিওঅ্যাক্টিভ না কেন? বিকজ লেট মি শো ইউ, এই যে পার্টটা আছে না, এই যে পার্টটা দেখতেছো, এই যে এইটার পিছনে কিন্তু আরেকটা টিউব আছে। ডু ইউ সি দ্যাট?
ইয়েস স্যার।
ওই যে ওইখানে একটুখানি দেখা যাচ্ছে, বেশি ভালো না।
এটা আগে দেখি নাই স্যার।
ওই যে আচ্ছা এখন দেখো, the thing is this water is pumped over here, ঠিক আছে? This thing is pumped into these high pressure heat exchangers. They are going to flow through those tubes and eventually they are going to come out. Let me put them back. Okay, exactly. So they're going to come out through that tube and they're going to eventually transfer to another set of pipe which is not shown in this figure, which is going to be connected to that input part. And whenever they are within these copper tubings, then they are going to exchange the heat from the inside through the copper tube to this water, which is shown over here. This water is the secondary water output channel, which is run through this pipe. So এখান থেকে ওয়াটার ফিড হবে, এটার পিছনে আরেকটা ফুটা থাকতে হবে যাতে করে আমাদের ওয়াটার, মানে আমি যদি পরের ফিগারটা হয়তো একটু ভালো বুঝবা। এই যে দেখো, এটা হচ্ছে আমাদের প্রাইমারি ওয়াটার সাইকেলের প্যাথওয়ে। একদিকে ঢুকে একদিকে ওয়াটার বের হয়ে আসছে, দেখছো?
জি।
কিন্তু ভিতরে কিন্তু পুরোটা ওয়াটার, এই পুরো ওয়াটারটা কপার টিপের ভেতর দিয়ে ফ্লো করতেছে, বের হচ্ছে না। There is no physical mixing. There is only heat exchange. There is no physical mixing. And the cold water, the secondary water comes in from here in liquid state, taking heat from the copper tubes. They become steam, and then steam then goes up through this pathway.
And then it is used to run the turbines.
Then it is used to run the turbine, exactly, precisely.
So তাহলে স্যার এই প্রাইমারি যে ওয়াটারটা আনা হয়, প্রাইমারি সার্কুলেশনের ওয়াটারটা থেকে হিট এনার্জি অ্যাবজর্ব করে আমরা হচ্ছে সেকেন্ডারি সার্কুলেশনের ওয়াটারের মধ্যে দিয়ে, আর সেটাকে পরে
Often comes from an adjacent.
Exactly. হ্যাঁ, যেটা বলছো পারফেক্ট বলছো, এটাই।
জি
স্যার, প্রাইমারি ওয়াটারটা যখন অনেক বেশি হিটেড আপ হয়ে যায় বিকজ দ্য প্রোডাকশন ইজ লার্জার দ্যান দ্য অ্যাবজর্পশন, তখন কোন চেইন অফ ইভেন্টস কজেস দ্য মেল্টডাউন একটু দেখাতে পারবেন?
মানে what are the sequence of events?
Sequence, হ্যাঁ, যে over time the heat has become extremely large. Okay, then what happens?
This can vary from reactor design to reactor design, but one of the things that I did come across for step of happening in the mini series Chernobyl. In the Chernobyl series, the scientist was actually explaining that what was actually happening inside the reactor, so that the chain reaction did happen. That is one actual that I could make sense with. তোমরা Chernobyl দেখছো?
জি স্যার, ডকুমেন্টারি আছে অনেক ভর্তি।
ইয়েস স্যার।
Yes, sir.
যারা চেরনোবিল দেখো না চেরনোবিল দেখবা, আব্বু আমাকে বলবা যে স্যার এটা দেখতে বলছে, এটা আমাদের ফিজিক্সের জন্য দরকার।
স্যার কোনটা স্যার?
হ্যাঁ
মানে এটা পার্টিকুলারলি নাকি আর
কোনো
কোনো
মুভি আছে?
না না না, চেরনোবিল মিনি সিরিজ, 7টা এপিসোডের একটা সিরিজ বা
HBO সিরিজ।
নামটা একটু আরেকবার বলতে?
আর তোমরা যদি চাও আমি তোমাদের দেখানোর ব্যবস্থা করতে পারি, জুম দিয়া।
ব্যবস্থা করে দেন।
জুম দেন না, মেসেঞ্জার দিয়ে দেন। জুম দিয়ে করলে
আমি 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 তো দেখি আমার এফটিপি থেকে, আমার এফটিপি হচ্ছে এই যে এটা, এই যে ন্যাচারাল বিডি, এখানে আমি চাপ দিলে আমার ইয়া চলে আসবে, চেরনোবিল চলে আসবে। কিন্তু কথা হচ্ছে এই এফটিপি তো যারা ডট ইউজ না করো তারা তো ইউজ করতে পারবে না। ডট ইউজ করো কে কে?
আমি স্যার।
সো যারা ডট ইউজ করো তারা তারা এটা অ্যাক্সেস পাবা, যারা ডট ইউজ করো না তারা তো এটা অ্যাক্সেস পাবা না। সো হোয়াট আই ক্যান ডু, আই ক্যান প্লে দিস এন্ড আই ক্যান শেয়ার দিস ইন জুম।
স্যার এটা করলে কপিরাইট ক্লেম আসবে না?
We live in Bangladesh. I think that's explanatory enough.
আমায় নিব না তো
বাংলাদেশে আমাদের এই কপিরাইট ল থেকে আইসিটি ল নিয়ে বেশি অ্যালার্ট হওয়া দরকার। তোমরা কি আইসিটি ল পড়ছো জীবনে?
নো স্যার।
আইসিটি লটা একটু পড়ে দেখো।
ডিজিটাল সিকিউরিটি ল। জি স্যার।
মানে ওখানে যে ম্যাটেরিয়াল আছে, মানে ইউ শুড বি কশাস ফর হোয়াট ইউ অ্যাবাউট ইউর অনলাইন প্রেজেন্স। ইউ শুড বি, আই এম নট কিডিং ইউ, দিস ইজ নট এ জোক। আচ্ছা এনিওয়ে,
স্যার ভিপিএন ইউজ করলে
এখানকার সব কোশ্চেন আনসার পাইছো কিনা সবাই? বুঝা গেছে পুরো প্রসেসটা?
ইয়েস স্যার।
সো আমরা যদি এখানে আবার চলে আসি, সো এটা হচ্ছে পার্ট। সো এখানে এই জিনিসটা হচ্ছে, এই জিনিসটা এখন এখানে শেষ। আচ্ছা এরপর নিউক্লিয়ার ফিউশনের বেসিক আইডিয়া, নিউক্লিয়ার ফিউশন আমরা আগে কভার করছি, ব্যাকগ্রাউন্ড রেডিয়েশন আমরা আগে কভার করছি। এখানে আমাদের ব্যাকগ্রাউন্ড রেডিয়েশনের একটা ছোট একটা ফিগার দেখানো আছে। এই ফিগারটা একটু বুঝো, দাঁড়াও আমি এই ফিগারটা বোঝার জন্য আপাতত ওয়াটারমার্কটা রিমুভ করে দিই। এটা একটু পড়ে দেখো কি আছে এখানে। টিপিক্যাল যে ব্যাকগ্রাউন্ড কাউন্ট হয় একটা সার্টেন এনভায়রনমেন্টে, যে ব্যাকগ্রাউন্ড কাউন্ট হয়, এইগুলা হচ্ছে একটা পাই চার্ট যে ব্যাকগ্রাউন্ড রেডিয়েশন কিসের জন্য হয়। ইফ ইউ ওয়ান্ডার ফুড আর ড্রিঙ্কের মধ্যে ব্যাকগ্রাউন্ড কাউন্ট হয়, দ্য আনসার ইজ ইয়েস। ফুড আর ড্রিঙ্কস ডু হ্যাভ রেডিয়েটিভ ক্লোরিন, দে হ্যাভ রেডিয়েটিভ কার্বন 12। সো আমাদের বডির মধ্যে তো কার্বন 12 আছে, কার্বন 14, সো রেডিয়েটিভ কার্বন 14। তো ওগুলো তো কন্টিনিউয়াসলি ব্রেকডাউন হচ্ছে, স্লোলি হচ্ছে বাট হচ্ছে তো। সো এটা হচ্ছে এটা, এর মধ্যে এইটুকু হচ্ছে আর্টিফিশিয়াল সোর্স। আর্টিফিশিয়াল সোর্সের সবচেয়ে বেশি পার্ট হচ্ছে মেডিকেল ইউসেজ। নিউক্লিয়ার পাওয়ার এন্ড ওয়েপন্স টেস্ট থেকে হচ্ছে এইটুক, আদার সোর্সেস হচ্ছে এইটুক। এই আদার সোর্সটা কি এটা একটু প্রশ্নবিদ্ধ, এটা আমি আপাতত আলাপ না করি, বাট মেবি আই থিংক আই ডিসকাসড ইট ক্লাস আর্লিয়ার। unauthorized nuclear warfare, I mean.
So যে ময়লা নিউক্লিয়ার ওয়েস্ট ঢুকাই দেয়।
Exactly. So এটা হচ্ছে একটা জিনিস হচ্ছে যে the background count happens to have increased significantly over in our regular environment compared to 40-50 years earlier. The only reason is that we have significantly increased this amount of the fraction by doing more nuclear testing and more nuclear fission materials and everything. So that's why we have a much higher background count, significantly higher background count compared in natural environment compared to earlier. Background radiation is considered to be one of the main reason to support the idea of evolution. আচ্ছা এই পার্টটুকু একটু পড়ো সবাই, এই পার্টটুকু একটু পড়ো, কোনো কোশ্চেন থাকলে আমি বুঝাচ্ছি।
Sir, buildings and grounds and radon gas from the ground. এই দুটোর মধ্যে ডিফারেন্সটা কি?
Radon gas from the ground is one of the individual single isotope which is responsible for the most amount of natural radioactivity, and buildings and the ground are basically applicable for the choice of construction material and also the location. For example, let's say if a certain location do have uranium ore underneath that surface, that part should have much higher background count compared to the rest of the world. That's one thing. And building material is also seem equally applicable. For example, if you choose a sort of building material where you used cement or irons which were collected close to a nuclear nuclear mining or location, then you might also have high presence of those things in those parts. It's about the choice of material, to be honest. I mean, let me put it this way. I mean, this might make better sense to you. If you consider the regular natural environment, what is there? Soil, trees, animals, right? Is there any house?
No, sir.
But whenever you make a building, what are you doing? You are producing 4 additional local source of wall or ground around you, right? So naturally, I mean, ground থেকে যতটুকু natural radioactivity পাইতাম, whenever I'm surrounded by 4 walls, shouldn't I also get additional radioactivity from the walls?
Sir, inspection হয় না আগে?
Inspection, I mean, all of the natural radioactivity is basically something that our body can cope with it up to a certain level. Inspection তুমি অবশ্যই করবে। ইন্সপেকশন করে তুমি মানে ইন্সপেকশন করে যে সকল জায়গাতে মনে করো হাই লেভেল অফ রেডিয়েটিভিটি পাওয়া পসিবল, those places are more valuable to their owners or to the country as a location for nuclear resources to be found. So ওই জায়গাগুলো অ্যাকচুয়ালি বাসাবাড়ি বানানোর থেকে মাইনিং করার জন্য বেটার। বুঝছো কি বললাম?
ও স্যার,
বলো।
ইউরেনিয়াম যারা মাইন করে বের করে ওদের কি কোনো প্রবলেম হয় না?
Well, this process is mostly automatic, but obviously people who has to work in those plants are do undergo a lot of health hazard. They do. I mean, if you are interested to find about this, you can always Google and come up with a lot of controversial, some true, some false kind of documentation and information in the internet. It's all out there.
Yes.
But if you consider some of the most highly paid job in the world, one of the most highly paid job is this thing, people who actually work inside a nuclear reactor or are physically involved in nuclear power plant management or nuclear waste management. That's one of the second high paid job is people who do deep water diving and those kind of job. For example, let's say people who do submarine cable repairing or they work in oil derricks or not derrick, মানে oil extraction platforms, or you have to go deep under the sea and do some welding or extraction or repairing. I mean, deep sea jobs are really high paid jobs because they require a lot of physical strength, and these people cannot work for a really long time for that within this environment. And this is also a task of extremely high professional skill. কি বুঝলা?
অনেক কষ্ট করতে হবে জীবনে।
তাহলে কি পেট্রোলিয়াম ইঞ্জিনিয়ারিং ইজ ওয়ান অফ দ্য হাইয়েস্ট পেড জবস?
Depends how cost, with how much price can you sell petroleum. But petroleum jobs are pretty good. I mean, here's the deal. I mean, let me put it this way. I mean, although it might sound bad, but here's this thing. How much money you are going to make out of your job is entirely dependent on how good you are at that job. Simple. If I am the kind of a scientist who is interested in shit, literally, and I'm the best in the world to deal with all sorts of shit, I'm going to be highly paid than many other people in the entire damn world. Like that. You have to be good at what you are doing. That's it. It doesn't matter what you are doing. As long as you are good in what you're doing, you are always going to get paid well. Simple.
Sir, earlier you mentioned...
serious একটা কথা ছিল না যে go for excellence, success will follow. This is entirely true. If you go after success, you will never find success because that's always 2 steps ahead of you. You'll never be contented. You go for excellence, you go for perfection, success will follow. Success will be a byproduct of your development. That's how it should be. Money should be a byproduct of your efforts. Money should not be your aim. বলো।
স্যার আর্লিয়ার হচ্ছে এভলিউশন নিয়ে কি একটা মেনশন করেছিলেন না, ওটা কি ব্যাকগ্রাউন্ড রেডিয়েশনের সাথে রিলেটেড?
হ্যাঁ এটা এক্সপ্লেনেশনটা বলছি, এটা এক্সপ্লেনেশন মনে নিচে লেখা আছে কি? আচ্ছা নিচে আর লেখা না। আচ্ছা জিএমটিটা তোমাদের একটু বুঝাবো। এই যে background radiation is thought to be the reason of cell mutation and the basis of evolution process. The idea is this. I mean, one of the idea is that there were single cellular organism, then we have multicellular organism, then we have organ developing organisms, then we have the division of plants and animals. So how did we came across all of these different type of species from a single cell organism of, let's say, amino acid? Okay, so one of the ideas that they say is that this happened because of the background radiation, and there was a significant change within the genome of the code, which the animal's body decided to keep as an acceptable and valuable change. This kind of changes over the time created all these species. So, I mean, that's the idea that they say. But one of the things that I really need to understand, I mean, because I'm a believer in Allah and the creation idea, so what I believe is that, I mean, this process does make sense, but to make this process happen, the amount of controlled radiation, the amount of controlled mutation you're going to require are going to be highly unprobabilistic. If I put it in a way, is that one of the example that I can, I mean, this is just, I'm just trying to share, I'm trying to share my ideas with you, is that, I mean, having human beings built up in the process of evolution from an early Earth is sort of like an example that, let's say you have a printing press and you have paper, ink, the electricity and everything, then you set up the printing press in dynamite, and the whole printing press goes blow up and comes out fresh copies of dictionaries. If evolution is supposed to work that way, this is an example of how probabilistic that is possible. Do I make sense?
So sir, early life background radiation ki low chilo comparatively naki high chilo?
It was comparatively higher. It was comparatively higher. That's why too many species got, I mean, according to the scientists, too many species got produced over a very short amount of time. I mean, as the Earth got cooled, the Earth's magnetic field becomes more stable, and the ionosphere got thicker and thicker. We got less exposure of background radiation, because when the Earth's magnetic field was not very well developed and the ionosphere was not so big, cosmic radiation was extremely high, which would reach up to this part. For example, the amount of background radiation that I would naturally experience being under open sky is far too less compared to an astronaut if they would expose it on the surface of Moon, because there is no atmosphere, so all the cosmic rays radiation directly fall onto the surface.
But sir, radiation to harmful hor kotha na living beings er jonno?
It is beyond a certain point. Like I said, our immune system is capable to handle to a certain level of radiation. Our body can handle that.
So sir,
আপনার প্রিন্টারটা একটু আরেকবার রিপিট করুন।
কোন পার্টটা বুঝেন বলো?
ওই যে স্যার প্রিন্টার নিয়ে প্রিন্টার ইন্টারেস্টিং লাগতেছিল।
কি প্রিন্টার সাউন্ড?
না স্যার, আপনি প্রিন্টার একটা জিনিস বলছিলেন না, প্রিন্টার ডায়নামাইট, ওটা আবার বলেন প্লিজ।
মানে হচ্ছে, if you try to assume that through the combination of carbon, hydrogen and nitrogen and oxygen, a complex life, let's say like human beings, or like, let's say like cockroach, that came into existence, I mean, through these things, I mean, this is sort of an example that every element that we require for life to happen on Earth was present on Earth. That goes without saying. But how much probabilistically, how much is it possible to actually have that thing happen from the stuff that we did have available on Earth? That probability is something like that. That let's say you have a printing press where you have blank paper, you have printing blocks, you have electricity, you have ink and everything that you require to print a book is there. And then you set up the printing press in dynamite, and out of that explosion comes out fresh copies of printed dictionaries. the probability for that to happen is somewhat like the probability for human beings to come through evolution process.
স্যার কিন্তু ফসিলস তো পাওয়া গেছে।
Exactly.
স্যার এক্স্যাক্টলি বলতে
আচ্ছা আমি এখানে এখন থিওলজি নিয়ে আলাপ না করি, I really don't want to go through theology, but I have my set of beliefs, but this is something that you should write in your answer, that background radiation implication কি, এগুলো হচ্ছে background radiation implication। আচ্ছা জিএম টিউব কিভাবে কাজ করে সেটা আমি তোমাদের একটা ভিডিও দেখাবো। Hold up.
স্যার এমনিতে এভলিউশন থিওরিটা কি প্রুভড হয়েছে?
It depends upon what you want to believe. I cannot solidly answer this question. There are enough proof that evolution should be true, and there is enough proof that evolution should not be possible. Evolution is not a good idea.
স্যার আমি একজনের ভিডিও দেখছিলাম স্যার, ও বলছিল
কি বলছে?
না স্যার ওই যে একটা কি জানি ইউসুফ নাম, ইউসুফের কথা বলতেছি না, একটা হুজুর ওরকম তোমার এভলিউশনকে কেন কারেক্ট এটা বোঝাচ্ছিল।
এই ভিডিও তো প্লে হয় না।
কি
এটা কতক্ষণের ভিডিও? 4 মিনিট। আচ্ছা এটাই দেখি আমরা। রেডিয়েশন প্রোটেকশন যাচ্ছে, রেডিয়েশন ডিটেক্টর যাচ্ছে, এটা দেখবো না, এটা দেখবো ওয়ার্কিং হচ্ছে মুলার কন্ট্রোল।
How does a Geiger Muller counter work?
What?
When an outwardly variation enters the counter.
That was pretty interesting. Hi, the resolution kharab. Hi. 1 to 240p. আচ্ছা
বুঝতে পারতেছি।
দেখো না বুঝলে আমি বুঝাই দিব, আপাতত দেখো।
Geiger-Muller, or GM counters, are one of a class of gas-filled radiation detectors that operate by using the ionizing nature of alpha, beta and gamma radiation. Neutron-sensitive devices can also be produced, typically by introducing boron, which interacts with the neutrons to produce secondary ionizing particles that trigger the count response. The GM tube is a sealed metal cylinder containing a low-pressure inert gas such as argon or neon. A thin metal wire runs down the centre of the tube, which is electrically insulated from the outer cylinder at the rear of the tube. The front of the tube is sealed with a radiation window that is specific to the typical radiation to be detected by the counter. For example, a thin mica window is used if the tube is to be sensitive to alpha particles and low-energy beta particles, both of which have low penetrating power. A thicker window, or a different material, such as glass or a thin sheet of metal, is used for high-energy beta particles, while for gamma rays the tube is often sealed without a window. In such tubes, the detection occurs when the high-energy photons liberate electrons from the tube's outer wall. The inner wire and the outer cylinder are maintained at a potential difference of about 1 kilovolt, and in the absence of radiation, no current can flow through the inert gas between the central anode and the outer cathode. The connections are made via wires into a connecting housing that fits over the rear of the tube. An outer tube guard will typically screw onto this to protect the actual GM tube. This tube guard can be open at the end or be covered by an end cap energy filter to change the energy and particle sensitivity of the device, or, if a carefully calibrated design is used, allow for ambient dose measurements rather than ambient count measurements to be made. The wires connect the tube to the control electronics, which supply power, perform the counting operations, and provide other functions such as conversion from counts to dose, data logging, data averaging, and driving the display. The tube works on the principle of gas amplification. Incoming radiation ionizes some of the inert detector gas, resulting in a free electron and a positively charged ion. The electric field inside the tube attracts the charged ion to the outer cathode, while the electron is attracted towards the central anode. As the electron approaches the anode, the electric field it encounters grows in strength so that the accelerating force increases. Near the anode, the acceleration is such that the electron has enough energy to either excite the electrons in other atoms of the detector gas or to ionize them completely. Excited electrons quickly decay, releasing photons that can trigger ionization farther along the tube, while electrons freed by ionization can go on to cause further ionization, leading to an exponential growth. This is often referred to as the avalanche effect. The charge migration in the tube leads to a reduction in the potential of the anode and an increase in the potential of the cathode, either of which may be detected as a signal by the counter electronics. As the negative charge around the anode increases, the effective electric field is reduced, and eventually this reduction is such that further avalanches are not possible and the tube can no longer detect radiation. This state persists until sufficient electrons have recombined at the anode and positive gas ions recombined at the cathode so that the field has recovered enough in strength to trigger another avalanche. This is the so-called dead time of the detector, the time after a detection that the counter is insensitive to further events, and its existence means that the detector count rate must be corrected to give the actual count rate. After the dead time, further detections are possible, but with reduced signal strength. The total time that elapses before the full strength signal is produced by a subsequent event is called the recovery time.
এখানে অনেক কিছু ডিটেইলস আলাপ করছে, তোমাদের এত ডিটেইলসে লাগবে না, তোমাদের বেসিক্যালি জিনিসটা বোঝা লাগবে সেটা হচ্ছে ionizing radiation is going to enter this chamber GM tube, which is typically covered with a thin mica sheet. Mica is a strong enough material to sustain the air pressure difference because this is very low pressure argon gas, and yet thin enough to allow to enter thin enough to allow the alpha particles to penetrate through, or low energy beta particles to penetrate through, because alpha particles have very low penetrating power. So whenever the ionizing radiation enters over here, they ionize argon gas over here, and the electron gets absorbed into the central rod, which is the anode, which is high positive volt, and that absorption of electron produces a small pulse of current into this wire. This pulse current would be gathered into this device as a single count. So every single pulse of current means that this GM tube detected one ionization inside its tube. That ionization must have come from the effect of one ionizing radiation entering the tube, which meant that this thing is aimed at a certain source where there occurred one nuclear decay. So one pulse of current was possible by one ionization, which happened by one ionizing radiation, which came up from one breakdown. That's how the GM tube does the count. Every single pulse of current is considered as one decay that happened, some source that is placed in front of the GM tube. That's the basic idea.
Sir, arekbar bujhaben please.
Please sir bujhay দেন।
Ionizing radiation will come, it will ionize the low pressure argon atom, it will release an electron will be absorbed by the high positively charged central cathode anode wire, which will produce a small pulse of current, which means a very small duration, high current, a small pulse of current through this wire. That pulse will be detected over here as one count.
As one
breakdown count.
Oh, each pulse of the current as a result of the ionizing radiation releasing one electron from the argon, making one ion and one electron, একটা charge difference করে releasing a current. That pulse of current goes into the electrical stuff and comes in as one breakdown count.
Exactly.
That means it can only detect one breakdown at a time because of that recovery period and dead period stuff.
Well, no, you don't have to understand the recovery and dead period. এটা তোমাদের সিলেবাস নেই, এটার মেকানিজম আমাদের লাগবে না, দরকার হলে পরে আলাদা করে বুঝাচ্ছি. What you need to understand is that how does it detect that the count. So one pulse of current is possible by one electron getting absorbed over here, which must have happened by one ionizing radiation, which must have produced by one breakdown somewhere from the source that is placed in front of here. So one breakdown, reducing one ionizing radiation, one ionization, one electron, one pulse of current, one count. Like that.
স্যার ওই যে ভিতরে যে আয়নাইজ কোন আর্গন অ্যাটম কি ওইটা ডিটেক্ট কি করতেছে, কোনটা ডিটেক্ট করতেছে এটাকে মাঝখানে থিন?
After the ionization, the positive ion gets attracted towards the peripheral cylinder, which is highly negatively charged, and the free electron gets attracted to the central thin wire, which is highly positively charged, and that thin wire produces the pulse of current into the device, this rectangular device.
Okay, sir.
GMTV এর একটা বেসিক একটা আইডিয়া দেখাই তোমাদেরকে।
আর্গন গ্যাসটা চেঞ্জ করতে হয় না?
কি বলছো?
আর্গন গ্যাসটা চেঞ্জ করতে হবে।
না, আর্গন গ্যাস চেঞ্জ করতে হয় না। আর্গন গ্যাসটা তো পার্মানেন্টলি আয়নাইজ হচ্ছে না। আর্গন গ্যাসের একটা অ্যাটম যখন আয়নাইজ হলো, ওটার ইলেকট্রনটা তোমার অ্যাবজর্ব হয়ে গেল এবং ওই অ্যাটমটা, ওই আয়নটা, আর্গন অ্যাটমটা তোমার সেন্ট্রাল রডের রিপালশন এবং হচ্ছে সার্কুলার বাউন্ডারি ওয়ালের অ্যাট্রাকশনের জন্য বর্ডারে চলে যাবে। বর্ডারে গিয়ে ওখান থেকে আবার সেই ইলেকট্রন নিয়ে আবার সে নিউট্রালাইজ হবে। The argon gas has a continuous supply of electron from the cylindrical wall.
সিলিন্ড্রিক্যাল ওয়াল তার ইলেকট্রন সাপ্লাই করতে থেকে পায়।
ওটা ওই যে ওয়্যারটা আমরা যে কাউন্টারটা কানেক্ট করে আছি, ওই কাউন্টার ডিভাইসটা কানেক্ট করছি, it produces a very high voltage across the central wire and the circular wall. The circular wall is a high voltage cathode connection, and the central wire has a high voltage positive voltage anode connection.
Yes, sir.
বলতো ট্রান্সফর্মার কেন জ্বালাই দিছি? No, don't get the wrong idea. Not to show you Megan Fox.
What?
What was that? You eyeballing my piece, 50 Cent? Oh, you wanna go? He wants to hurt us, and we've done that already.
Transform back.
No, you're done. Use it.
Now, how about that?
You know, I buy half your car.
You gotta do something.
Uncomfortable, you can.
It's an option.
Will. Your son's the great-grandson of isotope reading.
Out of the ground! Good Lord!
This is what these people are doing. They are checking for radioactive ionizing radiation coming out of the house around them to check for whether these people or this environment or this house or staffs around this house has come in contact with the transformers, who are supposed to be highly radioactive in their metal content because they travel through the large space of the space. So they are looking for more count rate compared to a natural background count. That's why they're gonna aim some sort of device at everything, and that thing is gonna give you click, 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 click sound. That each of these click represent one ionizing radiation, one nuclear breakdown happening on the face of that GM tube. These devices, one of these devices is gonna go like that whenever they're gonna aim into this person with Wiki.
Backpack mode.
Oh, let's go. It's in the kitchen.
So 67 people are coming. The interesting part.
Oh, yes. Okay.
Your mom's so nice.
I want you to distract my parents while I slip out and get these glasses, Finn, okay?
Ronald Wickety?
It's Witwicky. Who are you?
With the government. Sector 7.
Never heard of it.
Never will. Your son's the great-grandson of Captain Archibald Wickety, is he not?
It's Witwicky.
May I enter the premises, sir?
Ron, there's guys all over the front yard.
What the heck is going on here?
Your son filed a stolen car report last night. We think it's...
Ron, they're everywhere. There's guys in suits all around the house. Look at this.
Just stay off the grass.
Give me a sample and some isotope reading.
Out of the ground. Good Lord. They gotta get their hands
That is a GM tube.
off my bush.
We're off the bat, ma'am. I'm carrying a loaded weapon.
But you better get those guys out of my garden or I am gonna beat the crap out of them.
Have you experienced any flu-like symptoms, aching joints, fever?
No.
What is this? How you doing, son? Is your name Sam? Yeah? Oh, I need you to come with us.
What? Way out of line.
Sir, I am asking politely. Back off.
You're not taking my son. Really.
You're going to try to get rough with us?
No, but I'm going to call the cops because there's something fishy going on around here.
There's something a little fishy about you, your son, your little Taco Bell dog, and this whole operation you got going on here.
What operation?
That is what we are going to find out.
I think direct contact.
Son?
Yeah?
Step forward, please.
Just stand.
$14 rats. Bingo! Tag him.
There you go. That's what a GMTU is. কি বুঝলা?
That GMTU detected a large amount of nuclear break.
আজব জিনিস, ছেলেটা বেঁচে আছে।
On his skin, which means that he has been in contact with. That's what it means, that he has been in contact with much high radioactive content substance in the past couple of hours at least. So in their terms, in the Sector 7 people's term, that he might have been in direct contact with the transformers, which actually is the case. So yeah.
Sir, GMTU টা কি করছে? It detected the breakdown, right?
Yes, coming out of that kid's body.
এত radioactive elements থাকলে
Sir, each tick represented one breakdown, right?
Yes. He was having too many breakdowns coming out of his skin. That's why the device went continuous. Because like I said, that we can only hear 10 pulses per second. If anything produces more than 10 pulses per second, we're going to hear it as a continuous sound. You should know this from your sound chapter, right?
So it was still in the limit of humans to keep it like not be affected by it.
I am not entirely sure for how bad it is, but I would say that it's not necessarily normal. Okay. I mean, Sam Witwicky did develop some weird brain capabilities in part 2. Remember? Do you guys remember?
Yes.
Yeah. So that might as well be sort of a byproduct of his radiation exposure, which goes in line with the story. But from that point onwards, I mean, beyond the part 2, nearly every Transformer movie has been, in my opinion, quite crap. Any questions so far?
No, sir.
বুঝা গেছে কি দেখাইছি এতক্ষণ?
জি স্যার।
বলুন সবাই একটু এক্সপ্রেশন দাও। বুঝছি বা বুঝি নাই।
বুঝছি স্যার। বুঝছি স্যার।
If you're not using the voice channel, write in the chat channel. Okay, sir. Yes, sir. Well done, sir. Something. Oh my God, Abdullah called me a boy. It's so cute. I think we have 3-4 people left. Okay, that's pretty much it for the discussion part for the radioactivity chapter. So we have about 11 minutes left. For those 11 minutes, I can go ahead and discuss something else with you from the radioactivity chapter, which I believe is nothing left. Is there anything else in the radioactivity chapter? Yeah, let's go ahead and find out. I think so, but I'm gonna go through one last rain check. If nothing is left, I'm gonna call it a day. But this is the structure of the atom, nucleus and electrons. Describe how the Geiger transformer scattering experiment provides evidence for the nuclear atom. এগুলো বুঝছো? এখানে মুখস্থ বলা লাগবে না, আইডিয়া বুঝো কিনা?
জি স্যার।
স্যার আইডিয়া বুঝি।
এগুলি পড়ো।
স্যার
বলা।
স্যার অ্যাটমিক ফিজিক্স এর কোশ্চেন পেপারটা একবারে কোশ্চেন পেপার নেওয়ার পরে আপনার বুকলেটটা নেওয়ার পর শুরু করবেন নাকি তার আগে শুরু করে দেবেন?
সামনে তো ঈদ চলে আসছে, না আমি এখন ওয়ার্কশপ সলভ করাবো না, তোমাদের বুকলেট দেওয়ার পর সলভ করাবো ঈদের পর।
থ্যাংক ইউ।
স্যার নিউক্লাইড মানে কি?
nucleate means that notation. A shape writing formatটাকে nucleate বলে. For example, let's say Na is a sodium atom. Na plus is the sodium ion. Na2CO3 means the presence of 2 sodium in sodium carbonate molecule. Similarly, Na1123 means the structure of the nucleus.
So
it's just a way of
the
expression.
nuclide.
It's just a way of expression.
Expressing the atom, the nucleus, the electrons, etc., etc., right?
Yep.
Then
আচ্ছা এগুলো বুঝো, এগুলো পড়া আর কিছু নাই। এখানকার সবগুলো পয়েন্ট বুঝা হয়েছে সবার?
না স্যার,
কোন পার্টটা বুঝে না বলো?
মানে পড়া হয়নি স্যার, এই জন্য বোঝা হয়নি।
That's enough time to read that much English words. What are you doing?
No sir, not at.
পাগল।
স্যার এই নিউক্লাইড নোটেশনের পার্টটা বুঝি নাই স্যার, এটা একটু
এই স্টাইলে লেখার স্টাইলটাকে বলে নিউক্লিয়ার নোটেশন, where we are emphasizing or concentrating on what change is going to happen to the nucleus.
Okay.
Sir, what is the nuclide term?
বুঝি নাই, আবার বলো, তোমার কথা কেটে যাচ্ছিল।
Sir, term আছে না, the term nuclide, ওটা তো এক্সপ্লেন করতে পারতে হবে in words, ওটা কিভাবে লিখবো?
পড়ো।
So atomic species কি?
I have no clue.
Sir, আবার বলবেন atomic species কি?
I have no clue.
So nuclide is an atomic species characterized by the composition of its nucleus, number of protons, neutrons, and nuclear energy state, etc. The only thing I'm confused about is the species part.
Then how about you go start reading from here?
স্যার আপনার মেয়ে কেমন আছে?
ভালো, আলহামদুলিল্লাহ। She moves. I mean, she does not translate, but she vibrates. বুঝছো কি বলছে?
মানে কান্দে?
হ্যাঁ,
ওইটাই তো, ওই কান্দে ভাইব্রেট।
না, হাত পা নাড়ায়, কিন্তু সে গড়ায় এক জায়গা থেকে যেতে পারে না, so she doesn't translate, but she vibrates.
ওকে, কি ছিল?
Stays in the position but moves her, but has parts that those move.
ক্রল করতে তো না, আরো
উপর হইতে বহুত দেরি, মাত্র তো হইছে, 5 মাস লাগবে উপর হইতে, 6 মাস লাগবে হচ্ছে হামাগুড়ি দিতে।
স্যার নাম কি রাখছেন?
ফাতিমা। চলুন, বুঝা গেছে?
ধরে নিলাম, বুঝছি।
আলহামদুলিল্লাহ। Just to make you kids comfortable, I can look out for one more thing. Maybe I can, but I'm not sure if I
স্যার 4 নম্বর সিরিজটা কি করবে এখন?
ভাত দিয়ে মাখবো।
রাত্রেবেলা 12টা থেকে 2টা দেখি, চলেন জুমে।
আমি রেডি।
বই কই? বুকলেট প্রিন্ট না তো, আমি খুঁজতেছি হচ্ছে বুক। আমার বই নামাইছিলাম না, একগাদা বইগুলা গেল কই?
ফেডারেল
অনেক জায়গায় বই নামাইছিলাম, সব বইগুলা গেল কই, শিট। আমি যা নামাই সব হারাই ফেলি কেন? ও এই তো পাইছি। এইখানে তোমাদের 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 বই কই? তোমাদের বই এখানে নাই।
আর আপনি কি ফেডারেল ফিজিক্স খুঁজতেছেন?
না, আমি এক্স্যাক্টলি তোমাদের বইটাই খুঁজতেছি। আচ্ছা, তোমাদের বইটা নামাইতেছে, এখানে দাঁড়াও। তোমাদের সিআই বইয়ের নামটা বলো তো।
ফেডারেল
মেরি জোন্স নাকি কি বলে এর নাম?
ক্যামব্রিজ ও লেভেল ফিজিক্স কোর্স বুক। আর কোর্স বুক না,
কোর্স বুকে পিডিএফ আছে কারো কাছে?
আমার কাছে ফর এডুকেশন একটা আছে।
স্যার ছবি তুলে পিডিএফ বানানো যাবে?
লাগবে না, আইএসবিএন পাইছে, আইএসবিএনটা সার্চ করে দাও। আইএসবিএন দিয়ে তো হলো না, কি সমস্যা? আইএসবিএন অন্য বই দেখাচ্ছে না। এটা কি বইয়ের নাম কি? অ্যাপ্রোচেস টু লার্নিং। বইয়ের নাম কি? এটা তোমাদের বই?
না, রাইটারের নাম মেরি জোন্স। রাইটারের নাম দেখেন
ক্যামব্রিজ কি বই দেয়? এইটা স্যার। হ্যাঁ স্যার, এটা স্যার।
Sir, do you think this is a
আচ্ছা না,
এত টাকা?
এটা আইজিসিএস না?
আচ্ছা, আমি রেকর্ডিং পজ করি।